So the title of this presentation is Boost Your Terraform Automation. My name is Bruno Ferreira. I'm the proud father of a little girl, and I'm currently a cloud engineer at Motif. And I started to work with Terraform just a few months ago. If you worked with Terraform previously, your workflow might look a bit like this. So when you open a pull request, for example, you start by checking the format of the files. Then you will have to run Terraform init to initialize the backend and fetch the state that if you're using AWS, you might be storing your state in S3, in an S3 bucket, for example. And then you go for the Terraform plan. The Terraform plan, on the output of this comment, it's basically the changes that you will be doing on your infrastructure based on the changes that you did on your Terraform code. It says like, what are you destroying, modifying, or creating with your changes? And then after reviewing the output, if you're okay with it, you merge your pull request to master, and you go for the Terraform apply, and you perform those changes. If you're not okay with it, you fix with the new commit on the pull request, and you start the pipeline from the beginning. However, even if all the steps are okay, and your pull request gets approved and merged, boom, you fail the Terraform apply. And you might fail because you didn't create the IAM role with all the permissions, or you have a typo on your instance type. It can happen, lots of things that are not catched during the review process. And unfortunately, the apply comment is not transactional. So it might leave your infrastructure in an inconsistent state for some time. So what can we do to avoid that, or to avoid the risk of doing this kind of things? What I'm going to present here is some tools that might help you with that. The first one, it's called TF-Lint. It's a static analysis tool that is focused on best practices and possible errors. It enforces best practices like it catches unused var declarations on your code, and it forces you to have pins on the modules that you are using through Git source in order to have reproducible builds. It also catches possible errors that are not detected during plan. For example, invalid AMIs, invalid instance types, as I will show in the next example. It has more than 700 rules, and it also supports some custom rules, like if you want to enforce some patterns in your bucket S3 bucket names, and it supports multiple cloud providers. And here's an example. I opened the pull request and I changed the instance type to T3x micro, which doesn't exist. So another example is a GP10 EBS volume. Currently, there's no GP10, there's GP2, and more recently GP3. And also the AMI IDs, it also catches when you insert an invalid AMI ID. So these are the kind of errors that would fail on the apply, but they wouldn't be catched. Or if you have good reviewers, they would be catched, but yeah, it makes the process easier for you. Another tool, it's TerraTest. So it's a Go library to write automated tests for infrastructure code. So if you actually run your code before merging to master, this can help you also to catch some issues with the changes that you did. And currently, I try to use this in two different ways. The first one was with local stack. A local stack is basically it's a mock server for AWS. It mocks AWS for you inside a Docker container. And on your Terraform code, on the provider, you just have to overwrite the endpoint. So instead of calling AWS, you will be calling this container on port 4566. So all the operations on EC2 will be calling this container. All the operations on IAM will be calling also this container, and so on. And the code of a TerraTest looks a bit like this. You can set different options, the directory of your Terraform code, some environment variables like the AWS region. You defer the destroy of all the things that you create on the test to destroy the stuff after the test is run. you run it and apply, and in the end you do the assertion. So in this case, I'm just testing that the bucket name awesome bucket should have been created with bucket versioning enabled. It's just a simple test. However, every time that I try to use local stack, the concept seems good, but I spend lots of time fixing problems with the container. Like sometimes the container gets stuck and I don't know why, so I have to investigate why it got stuck. Or like sometimes for the assertions on Terra tests, instead of calling the endpoint of the local server, it's still calling the AWS endpoint. So I have to hack some stuff. So in the end, I spend more time fixing problems with local stack instead of taking value out of the test. So my advice to you is that if you want to use Terra test, use it with the real thing. You will take more value out of your test. It is way more reliable. So you can use, for example, a sandbox account that you can nuke it from time to time just to delete the stuff that might be pending there. So we can use AWS Nuke or Cloud Nuke to do that for you, like every week or something. Regarding security, we can also have some security checks using this great tool called Checkov. That's also a static analysis tool for Terraform. It has more than 400 rules for security and compliance best practices, supports multiple cloud providers, and it also scans CloudFormation, Kubernetes, and others, and it detects AWS credentials in your EC2 user data, for example, Lambda environment variables, and Terraform providers. Here's an example. Here I created an EBS volume, and I didn't enable encryption, so it reports it automatically for me. And another example is this S3 bucket that I created. It doesn't have access logging enabled, which might be useful in the future if I want to check who's accessing this S3 bucket. Another cool thing about this tool is the documentation. So you have a URL on every issue that it reports with the rationale for the issue, so you can also learn a bit about what is the tool complaining about, and that's actually really useful. Cost management. I was really surprised with this tool. I found it really useful, especially if you're on a budget. It's called InfraCost, and it's basically a tool to estimate costs automatically in every pull request. Here's a basic example. I opened a pull request that modifies the instance type from a T3 micro to T3 X large, and automatically on my pull request I get a comment saying that my monthly bill will increase from $114 to $239. So I didn't have to go somewhere else to check it. And even when you are doing more complex changes, you might not be aware of what implications it will have on your bill in the end of the month. So this is really helpful. This is a really helpful tool in my opinion. All of those tools and others that I showed here, I set up an example, a sample project on my GitHub account. It's called Awesome Terraform Pipeline. So if you want to experiment with these tools and others, like I also experimented with the tool to automate documentation for Terraform, etc. Feel free to go there and to also try and test these tools. Hopefully they will be useful for you as well. And there's much more. Like we have TFSec and TerraScan that are also tools focused on security. They are good alternatives to check off. We have Terraform compliance. If you are familiar with Cucumber, this is almost like a Cucumber for Terraform. You can have your test like given when then. I didn't spend too much time already testing it, but the concept really seems really cool. Yeah, you have lots of projects here on the awesome Terraform repo. Feel free to check it out. So thank you. Hope you enjoyed the presentation, and if you feel free to share also your experiences with Terraform tooling, I'm happy to hear it. Thank you.